Hey, welcome back to Engineers Workshop. So I mentioned in last week's video, it's time to have a little bit of fun and machine something that I'll bet you none of you have machined but always wanted to. And that is this. How many of you have machined a sledgehammer head? Now, why would anybody want to do this? Okay, so my son slips in a project on me. He has what I guess could best be described as a post anvil. So it's a piece of 2-inch pipe, and then he made interchangeable tips on it, mostly small, for doing hammering and swaging and things like that on his projects. But he basically wanted another one with a little bit bigger, face. So he wants to take a 2-inch pipe coupling, have me turn this down, he's gonna weld that together, and he's gonna be able to screw this on to his post anvil. And then he wants me to flatten the face, but give it a very, very shallow or large radius surface. And we talked about that. There's no real easy way to do that other than to machine a flat and then approximate with a couple of shallow angles what that radius would be, and he'll dress it up with the angle grinder. So the first challenge is, how do you hold something like this? I mean, it's kind of an octagon, but if you look at these faces, there's nothing that's really, none of them are pointing in any direction. So what I'm going to do, I'm going to put it in the K&T. We're going to use the fly cutter, dust that face off, dust that face off. That'll give me two parallel faces that I can then clamp in the vise vertically. And I'm going to use the K&T, and I'm going to mill a circle on here. Mill this diameter at the one end after I bore the coupling out to fit. And then that'll give me something that I can chuck on that's true to the basic axis of this guy. And then I'll put it in the lathe, and I'll face this end, and we'll figure out the angles, what we got to do later. So let's go ahead and set this up in the vise and use the fly cutter that I got from Cody Schmidt. First thing is to establish a reference diameter, boring out the 2-inch coupling. Isn't that nice? 2.375, and I didn't even try to hit any specific number. I guess I can get about a little bit, thousandths or so over. That's our weld prep. We got some of this dead soft aluminum wire. This is like tie wire from line poles, what they use to wrap around the insulators when they tie the conductors onto power transmission lines. And it makes great soft jaws or inserts for the vise. I'm going to cut a couple pieces of this, and then that way the irregularities of the hammerhead here will not affect how this thing clamps. I have a different lathe tool in here. It is a brazed carbide piece, and it's going to be opposite hand rotation. I don't know how well that's going to work out, but I'm going to go ahead and give it a try. Like I said, I don't know how flat or parallel this hammerhead is. I think I'm going to have to run this in very close to the column so that I have clearance. I don't have to unclamp my radial arm piece here. I might have to anyway. Yeah, let's do that. Otherwise I'm going to run into it. I'm going to have to slow my rotation back down to where it was because I've got increased stick out, and the I'm just using, you know, diameter chart for the lathe, and I got to get down to around 250 RPM. Okay, I'm very close to touching, so let's creep up on this. Got the table on its basically on its slowest movement, and I'm just increasing the depth of cut 0.005, and we'll see how we go as we move across. We might be running uphill, I don't know. I'll bring you back when I've made more progress. That first tool wasn't working so good, so I switched over to a stouter 3/4 inch square shank cutter and back to left-hand rotation. Just a few thousandths depth of cut. Switched over to an M2 roughing mill because it was getting very thumpy with the fly cutter. So we'll do this, see if a 20 thousandths deep pass cleans everything up. And really what I'm looking for is just that those ends will clean up so that I can stand this up in the vise. So I think I would say that sledgehammer heads are fairly hard. I will do a hardness test on it when I get back over to the other shop, because I am curious to see what this thing measures out to be. gonna have to come down deeper so that this will clean up. Just need enough of a flat, tall enough to stand up in the vise, and I believe either one of these ends will do it now. Okay, I need to know my overall width, and what I'm going to do is zero on the back vise jaw, come up half this distance, which is 2.787. 2.787. See if I get that on the other end. I'm sorry, that was 2.767. And this end, 2.760. So I'm using my little 3/4 inch Joe Pye half step block, zeroed on the back face of the vise, zeroed my Y. Now I need to come forward half of 2.766, or 1.383. So 1.383. And then I would drop this, clamp the sledgehammer head in the vise, snugly get it vertical, and we'll take a width measurement of that. Maybe it'll help to put some light on the back side. I think we're touching. So we're going to zero the X and come over exactly half of 2.800. Was that our number? And I'm going to set an incremental 0 at that point. Okay, so here's my setup. I'm zeroed on the head of the sledgehammer. I'm going to offset my slide. And I'm going to use the rotary head axis to begin to remove the high sides until I've got a diameter of 2.375. I have no idea if these peaks are uniform. I'm going to call that flush with the surface, and I'm going to come down 100 thousandths. 1 inch depth of cut. I think I'll start the cutter, just start walking it around until I get contact at all 8 points. Okay, I just have to come in 20 or 30 thousandths at a time. Still a couple points I have not touched yet. I'm going to try a different tactic. The roughing mill was getting real chattery because there was a lot of, milling the last basically inch of it, and it's a long tool. So I switched over to my solid carbide cutter. I don't have full flutes on this because this one broke in the mill quite some time ago. But I should be able to get, maybe a 1/4 inch or so per pass. Maybe I can take a little bit deeper cut. Then I'll advance the cutter down and go around it, do the entire depth over maybe 3 rotations. This sounds a lot smoother. And I'm going significantly deeper. I should be climb cutting this. Keep the quill lock kind of snug because this thing will have a tendency to walk down or up under vibration, under heavy cuts. Once I come all the way around, I will check progress on the diameter. I still think we got a long way to go. Two inches 7/10, 335 thousandths. Quite a ways. That's a 30 thousandth step to cut, so 60 thousandths reduction in diameter. I go around 3 times for each one of those, times 5. It's about 15 rotations of the head. I'll bring you back when I'm closer. Well, I've had enough fun playing with the K&T, but now that I've got a consistent diameter and I know the center of this, I'm going to bring the head back to 0, put a center in this. That'll let me support the outer end of this sledgehammer head in the lathe, and using the 2 faces I milled, I can level it and get it squared up in the 4-jaw chuck. So it's going to be a lot quicker removing 300 thousandths of material in the lathe. So let's set up to do that. The smaller collets have a notch that enables you to load them after the center ring is on. It's just a little bit of a trick to make sure that they are trapped correctly. once it starts getting tight, what I do is I rotate it till it drops out. Okay, and then I turn back. That way, once it's tightened forward, I know that the entire tab is holding the smaller collet in place. Not ideal, but workable. That's the best finish I've seen on anything I've turned. That's unbelievable, and it must be fairly hard. Felt like it when I was drilling that center. I don't know if he's going to be able to weld this. I don't know what the carbon content is. I mean, that is a truly spectacular finish. This finish amazes me. I can literally see my reflection in it. I'm about 100 thousandths away from the final diameter of 2.375, taking about 20 thousandths steps on here. So we'll just continue to work this down until we're a light press. $380. All that thumping is making this run a little bit out of concentric. I just wanted to give him some room for a weld lead in if he can weld it. So we'll stop there. Put the big 3-jaw on and flip it around. That seems like a pretty decent stopping place, a halfway point. So we'll pick up next week, flipping the part around and working on that large radius face. I've come up with a way to do that I think is reasonable, even though I don't have a direct way to set the compound to machine those slight angles. I'm just going to use a trigonometry trick. I'll show you that. So hope you enjoyed seeing that steel machined so nicely. I'm still just so impressed by that. I don't know what it is. I'm going to do some more research. I saw one source say maybe A2. I'm going to do a Brunel test on it and see how hard it is. That way we'll know what we're working with. And if any of you guys want to duplicate those results, just grab yourself a Sledgehammer head. These were Stanley. And you know, my son picked these up for like 10 bucks at an antique store. And it's a good sized chunk of steel to make projects out of. So anyway, thanks again for watching and for subscribing. Share and like the videos, help grow the channel. And stay out of the weather this coming weekend. And as always from Engineers Workshop, until next time, stay safe.